Hi there, I'm Pete Scott. First thing that drove me crazy was the Electoral College. Never agreed with that. I was 9 years old watching Nixon Humphrey with Dad. The second thing that drove me crazy was any root number n raised to the power of 0 equals 1. And this was determined by convention by mathematicians, and I think it's crazy. Powers do not equal how many times you take a number times itself. Let's get that out of the way. Because if that was the case, 2 to the 1, you'd take 2 times itself one time. 2 times 2 equals 4. So powers are actually how many root numbers you line up side by side and then put time signs in between each one of the root numbers. So right here I took the root number 2, raised it to the 5th power, wrote down 5 2's, and then put an X in between each one. At one time I had actually figured out different symbols to do that with, but I didn't get that fancy this time. And you come up with 32. And that makes pretty good sense. Now by convention, 2 to the 0 equals 1. By my way, 2 to the 0 would equal 0. Because after all, if you're lining up, if you're lining up root numbers, you have nothing to line up. This space intentionally left blank, as they used to say in government stuff. So there's nothing there. So I call it 0. So my way says 2 to the 0 equals 0. Now, before I go on, we often think about roots raised to the power. It's always a whole number, 2 squared, 5 squared, whatever, 3 cubed, 27. It is okay to raise a root to the power of a non-whole number. Say, raise your root number to 3.5. That's okay. You don't only have to raise it to the power of a whole number. Now that's going to get us a lot of places. Now, let's see if we can find our way here. Now, what central theme I'm working off of is this. You should be able to take any root number n, raise it to a power, and you should be able to reach any number in the universe. Any number whatsoever. So that is the central premise I'm working off of. Now to reach any number using any root and any power. Now, by my way, n to the 0 would be 0. We'll start out there. We'll go up to 1. We're going to use the root number to its reciprocal. These are the same numbers, but one is the reciprocal of the other, and that takes us up to 1. And we all know that n to the 1 equals the root number itself. Now, to reach negative numbers, we would just take the root number, take it, mark the power as a negative, and that way you would be able to come up with any negative number in the universe. I'll be explaining this a little bit more coming up here. Okay, to reach any number y, where y is in between 0 and 1, we're going to start out at 0 and move up. So first thing we got to do is get to 1. And so using the power to adjust the root to get to 1, we need that power somewhere in between 0 and the reciprocal of the root number. And that'll take us up to 1. Now, to reach any number from 1 to the root number, we take the power x, make it the reciprocal of the root number n. Take any number above that up to 1, and you can reach any number from 1 to n, the root number, no matter what that root number is. Mine earlier was 2. It could be 240. It doesn't matter. So that's how so far we've gone from 0 to 1, and then now we've just gone from 1 to the root number n. Now, to get above that root number n, what you would do, since n to the first power equals n, anything above n would be equal to n to the first plus an adjuster, ADJ, and that would adjust it up until you reach the next power of 2, whatever. All negative numbers are covered with the negative power. I covered that earlier. To reach any number above a root number, like I was just talking about, you would take your root number to a power above 1. So we've tackled all the negative numbers. We've tackled 0 with the root number to the power of 0. We've tackled numbers from 0 to 1, and then we've tackled numbers from 1 to the root number. And this would pretty much take in all the numbers in the universe. And there are some problems here. Now, since we defined a long time ago that n to the 0 equals 1, then we would have to change engineering calculations to be in line, with the correct answer. But we could probably do that, and it may have proved simpler in the beginning. Problem 2 is powers drive root numbers up on an exponential curve. That's how they affect a root number. An exponent is kind of like a variable, only it's raising your root number up on an exponential curve, which is this right here. See how it's kind of curved? Now, when I calculated n to its reciprocal equaling 1, that's actually linear. And I hate to admit it because I really like this theory, but that's actually done on a linear curve. Now, there's nothing saying that we can't adjust this exponent to equal 1, adjust it from linear to exponential. So those are a couple of problems, but tell me what you think. I know I'm not the only guy out there that has thought about this. This is just something fun I do. I'm Pete Scott. I'm a disabled veteran, and I do this to help exercise my mind. And I thank you for watching.